In this session, we are going to see one of the different kinds of special concrete that is available. There are different kinds of special concretes available these days, such as sulfur infiltrated concrete, fiber reinforced concrete, lightweight concrete, aerated concrete. So in this session, we are going to see what is a fiber reinforced concrete. So we are going to see a brief history about fiber reinforced concrete, why a fiber should be used and what are the different kinds of fibers that are available, mechanical properties of fiber reinforced concrete and factors affecting the properties of fiber reinforced concrete, advantages and disadvantages of fiber reinforced concrete and applications of fiber reinforced concrete. So if at all we go back to the history of fiber reinforced concrete, it is not a new concept. It has been back at least 3,500 years ago. There was the studies have showed that there was a use of fibers, where straw was used to reinforce sun-baked bricks in Mesopotamia. Even they found horsehair was used in mortar and straw in mud bricks. Asbestos fibers were used in the concrete in the recent 1900. Steel, glass and synthetic fibers have been used to improve the properties of concrete for the past 30 to 40 years. Research into new fiber reinforced concrete continues even with today. So why a fiber should be used? See, generally concrete is not a ductile material. It is a brittle material. So plain concrete possesses a very low tensile strength, limited ductility and a little resistance to cracking. Internal microcracks are inherently present in the concrete, and its poor tensile strength is due to the propagation of such microcracks, eventually leading to brittle fracture of concrete. So the main idea of these fibers is to bridge such microcracks that develop in the concrete and increase the ductility of the concrete. So improvement in the post-cracking behavior of concrete containing fibers due to both plastic shrinkage and drying shrinkage. They also reduce the permeability of concrete and hence decrease the water seepage into the concrete, so that any kind of water or the liquid will not be stored in the micro cracks that are being developed in the concrete, and thus they reduce the bleeding of water and even more damage to the cracks already that are formed in the concrete. And these imparts more resistance to impact load. Not only impact load, they even increase the tensile strength capacity of the concrete and compressive strength also. So what are the different types of fibers available? So there are different kinds of fibers that are available in the market. There are steel fibers, carbon fibers, glass fibers, polypropylene fibers, nylon fibers, cellulose fibers, coir, hay and bamboo fibers. So actually we can divide the types of fibers as two kinds, that is natural and artificial. So if at all we see in this examples I have given here, steel, carbon, glass, polypropylene, nylon, cellulose, these are all artificial fibers or man-made fibers, whereas coir, hay, bamboo fibers, or else just like horse hair, which is used in the olden days construction, comes under natural fibers. So now let us study the properties that are improved in the concrete when we use each kind of fiber separately. In the past, attempts have been made to impart improvement in the tensile properties of concrete members by way of using conventional reinforced steel bars and also by applying restraining techniques. Although both these methods provide tensile strength to the concrete members, they however do not increase the inherent tensile strength of concrete itself. So the idea of fiber reinforcement or providing the fibers in the concrete is to increase the inherent or the internal tensile strength of concrete itself, rather than providing some other members to resist the tensile strength. So let us see about the steel fibers. So steel fibers, generally the aspect ratio is of 30 to 250. So now what is aspect ratio? This is a new term. So aspect ratio is described as ratio of the length to the least lateral dimension. So generally that may be a diameter of a fiber, or the length or the the breadth or the depth, whichever is less. So I can say it is L by D ratio, where D is the smallest lateral dimension. So the diameters of these fibers vary from 0.25 mm to 0.75 mm. These provide high structural strength, and these are the most commonly used steel fibers. They reduce the crack width, control the crack width, and even improve the durability and ductility. They improve the impact and abrasion resistance also. These are generally used in precast and structural applications, highway and airport pavements, refractory and canal linings, industrial flooring, bridge decks, etc. So the next fiber is glass fibers. So generally, glass fibers have very good improvement of improving capacity of the impact strength of concrete and tensile strength of concrete. So they have generally inherent tensile strength of glass fibers is very high, that is 1020 to 4080 Newton per mm square, and these fibers are of generally 25 mm in length, and they improve the flexural strength, ductility, resistance to thermal shock, and impact strength also. So these are used in the formwork, swimming pools, ducts and roofs, sewer lining, etc. Next one is synthetic fibers. So I can say polypropylene, cellulose, all these fibers comes under synthetic fibers or man-made fibers. So these are made from petrochemical and textile industries. These are cheap and are abundantly available when compared to the other kind of fibers. So these are highly chemical resistance. So if at all we are looking to control the parameters like sulfur attack on the carbon attack on the concrete, or else aggressive pollution attack on the concrete, you can go for such use of these fibers because they are chemically inert or inactive. So these have high melting point, which means that they will improve the thermal properties of concrete. They have very low modulus of elasticity. Its types are acrylic, aramid, carbon, nylon, polyester, polyethylene and polypropylene, etc. Generally these are also used in cladding panels and shotcreting. So I told you there are also natural fibers available, that is coir and hay. So these are obtained at a low cost, low level of energy using local manpower and technology. The thing or the disadvantage with this kind of fibers is they provide some improvement in the compressive strength as well as tensile strength in the concrete, but these may undergo organic decay. So but these also improve a very good impact strength of the concrete. So let us see the mechanical properties of fiber reinforced concrete. The fiber reinforced concrete is being studied by various researchers all over the world, and these are all the conclusions from different kinds of researchers. So improvement of compressive strength values up to 15%. Modulus of elasticity increases slightly with increase in fibers content. Flexural strength was reported to be increased by 2.5 times using 4% fibers. For fiber reinforced concrete, toughness is above 10 to 40 times that of plain concrete. The impact strength for fibrous concrete is generally 5 to 10 times that of plain concrete depending upon the volume of fiber. So this is a graph that shows the stress strain behavior of fiber reinforced concrete. So if at all you see here, so this is the graph of stress strain behavior of a plain concrete, which is a sudden drop in the graph indicates that it is a brittle failure but not a ductile failure. So these both the graphs indicate the stress or strain behavior of a fiber reinforced concrete, and this is with the low fiber volume whereas a high fiber volume, which shows that the properties are better improved, or the tensile strength or the ductility of the concrete is better improved with high fiber volume. You can see the graph that is rising up here. So mechanical properties, I told you the first important property we require from the fiber reinforced concrete is arresting the cracks. So if at all you see, so this is a specimen without any fibers after compression test, and this is a specimen with fibers. That is, the failure is a very ductile failure. It is not a brittle or a sudden failure. The cracks are being held by the materials that are fibers. So what are the factors that are affecting the properties of fiber reinforced concrete? That is volume of fibers, with how much is the amount of fibers you are going to add in the concrete. Next one is the aspect ratio, that is the length of the fiber you are taking into consideration, and the diameter of the fiber you are taking into consideration. Orientation of the fiber, that is parallel to the load or perpendicular to the load. Next one is relative fiber matrix stiffness, that is stiffness of your fiber matrix. So what are the advantages of fiber reinforced concrete? You have high modulus of elasticity, this do not rust nor corrode, and this require no minimum cover. So easy placed, cast, sprayed, less labor service, greater retained toughness in conventional concrete mixes, high flexural strength, high thermal resistance of concrete, high impact strength of concrete, higher ductility of concrete, and fiber reinforced concrete possesses enough plasticity to undergo a large deformation once the peak load has been reached. So every material has got some advantages and disadvantages. So what are the disadvantages of fiber reinforced concrete? That is greater reduction of workability, which is the foremost important character of the concrete, so which has to be taken care of. Next one is high cost of materials. If at all we go with the glass fibers, if at all we go with the concept of glass fibers or steel fibers, these are rather costly materials. Generally, fibers do not increase the flexural strength of concrete and so cannot replace the moment resisting or structural steel reinforcement. They just improve, they cannot replace the structural steel, they just improve the tensile strength of concrete. So applications, you can use them in many places such as runway, aircraft parking, pavements, tunnel lining, slope stabilizations, dams, walls, pipes, agricultural equipments, agricultural irrigation canals, precast concrete products, commercial, residential, warehouse, industrial areas, etc. So these are the recent advancements, that is the transparent panels or the transparent cladding that is made with the help of fiber reinforced concrete. If at all you see, you have a visibility of flight or visibility of the materials that is to the other side of the cladding or the panel. This is done with a fiber reinforced concrete using fibers of synthetic materials, that is nylon, polypropylene, and etc. So thank you.